Hello, my name is Lan Jiang. I'm from Hasso-Plattner Institute, University of Potsdam, Germany. Welcome to my talk on structure detection in verbose CSV files. A verbose CSV file is a tabular structure that might contain not only tables, but also metadata regions. For example, in this file, there are metadata and footnotes of a table in the beginning and the end of the file. The table itself contains headers and data regions, but apart from that, it also contains group headers which are used to separate the table content into several sections. The table it also contains aggregation cells whose numeric values can be derived from other numeric values in the same column. One unique feature of verbose CSV files is the widely diverse structures. Here we show 8 different verbose CSV files randomly sampled from our datasets. We can obviously see their structure diversities by just looking at the color distribution of the cell classes. One reason that verbose CSV files have so different structures is that these files are usually created to store data that are meant to be read by humans instead of being processed by machines. Because of that, existing tools would either simply fail in loading these files or produce results that are not expected by the user. Despite the difficulty to automatically process verbose CSV files, there are a lot of such files all over the places. Due to the simplicity and generality of its format, verbose CSV files are often used to store spreadsheets content in plaintext files. And how popular are spreadsheets, I think there's no need to emphasize that here. However, according to some previous studies, more than 80% of the spreadsheets are verbose. Therefore, there should also be huge amount of verbose CSV files. Detecting structures of verbose CSV files is the first step to automatically leveraging the information stored in them. In this work, we studied the problem of detecting structures in verbose CSV files. Formally speaking, given a verbose CSV file and a set of content classes, structure detection automatically assigns a class to each line and each cell in the file. There have been already some related work regarding line and cell classifications in files. However, most of them are focused on dealing with spreadsheets or web tables, where, where rich text information can be easily retrieved. Such rich text informations are, for example, background color of a cell or font size of a cell. Such information have been proved to be quite useful by previous work in line and cell classification tasks. However, in CSV file, we simply lack these stylistic features, which makes the problems more challenging. We propose Studo, a system that automatically detects structures in verbose CSV files without using stylistic features. Given a verbose CSV file, Studo first detects its dialect. A file dialect specifies its utility characters, such as those for delimiter, quotation, escape, or line breaks. The file then can be properly represented as a tabular structure after the dialect is detected. After that, Studo applies a supervised learning approach to detect the file's line and cell classes. Results of line classifications are used as part of the features in detecting cell classes. As Studo is backboned by a supervised learning approach, one important task is to design useful features for it. We have designed a set of features for both line and cell classifications. However, due to the line limitation, we will only present those used in cell classification. For the complete feature set, please refer to our paper. All features fall into four groups: content, contextual, computational, and line class features. For content features, we exploit the information carried by the cell itself, such as the length of the cell value, the data type of the cell. For example, metadata and footnotes cells are often very long, and data and aggregation cells are usually numerics. The second type of the features describe the relationships between a cell and its context. Properties of cells in the context of an inspected cell can be quite useful to decide the cell's type. For example, a metadata or a footnote cell is often in a line with all empty cells except itself. And header cells, upper neighbors are often empty cells, as headers are usually the upper boundary of a table. The next type of features is the computational feature. We have observed that the values of aggregation cells can usually be calculated by aggregating values of those numeric cells in the same row or the same column. Therefore, for each numeric cells in a file, our computational feature checks if its value can be computed from those in the same column or row, and we check it for all the four directions. In this work, we consider two types of aggregations, sum and average. Last but not least, we consider the line type distribution derived from the previous line classification results. The idea behind this feature is if a line has been classified as a specific class, the cells in this line are also more likely to be of that class. To evaluate our approach and compare it to related work, we use 6 datasets from different domains, including administration data, business data, and academia data. Some of these datasets are from previous works, while others were quotes from the internet by ourselves. In the end, we have in total about 1,400 files and more than 400,000 lines and more than 4 million non-empty cells. All these lines and cells can be used to enrich the training set of our approach. We have compared our approach with related work on both line and cell classification tasks respectively. Regarding F1 score, Strudel outperforms the other approach on each of the single classes and the macro average. Compared to the data class, all the other 5 classes are minority classes. Nevertheless, Strudel reaches more than 0.8 F1 score for metadata, header, and footnote of them. However, we have also observed that group headers and aggregations are challenge classes for all approaches. We have also conducted error analysis on our results and come up 5 major difficult cases. Due to the time limitation, I will just explain one of them in this talk. One common mistake is classify aggregation cell as data cell. We have 2 explanations for it. First, such line often contains no aggregation keywords such as total, which are quite useful in separating aggregation cells from other types. Second, values of the aggregation cells are derived from non-consecutive data cells. And as a follow-up work, we are now studying how to make aggregation detection more effective. And this brings us to the conclusion. We studied the problem of classifying lines and cells in verbose CSV files, model it as a supervised learning approach, and introduce various types of features. Our approach outperforms the related work, and experiments shows that obtaining good line and cell classification results outcomes without rich text information is possible. Thank you, and I'm happy to take questions.